Okay, so welcome back to another video. So in today's video we are given the following. Suppose that there is a function f that maps from the reals to the reals, this being the domain and then this being the codomain, which is both differentiable and continuous, such that we have our following functional equation: f of x plus f of 1 minus 1 over x is equal to arctangent of x. And we're being asked to compute the integral from 0 to 1 of f of x dx. Okay. So let me actually just rewrite our given functional equation, and I'll just call that equation 1. This will be important for later for why we label these equations. Okay. I'll just call this equation 1. Now, how about next? Let's actually substitute our input for x such that x is replaced with 1 minus 1 over x. So that means this is f of 1 minus 1 over x, and then plus f of 1 minus 1 divided by 1 minus 1 over x equal to arctangent of 1 minus 1 over x. Okay, and now I can simplify this middle expression, this middle term over here. So therefore I would get the following. I would actually just get that this is just f of 1 minus x divided by x minus 1. Okay, 1 over x, and then this is labeled our second equation. And now we have this term again. So how about now let's go back to our first equation, and now let's substitute everything for x for 1 minus x divided by x minus 1. Okay, so that means this is f 1 minus x divided by x minus 1, then plus f of 1 minus 1 divided by 1 minus x divided by x minus 1, and then that's equal to arctangent of 1 minus x divided by x minus 1. Okay, let me also simplify out the our middle term. So when you actually simplify all this out, the middle term specifically, you're going to get that this is 1 minus x, x minus 1. That we're just going to get that it's just f of x, and then equal to arctangent of 1 minus x divided by x minus 1. Okay, that's equation 3. How about I underline these 3 equations? So this is 1, 2, 3. All right. And now notice that now that we have this systems of equations here. So how about instead to fix this, why don't we actually solve this, well, systems of equations. So how about I'll add equation 1 with equation 3, and after we combine those two functional equations together, how about we subtract the functional equation for 2. So this means if I let's see, if we do 1 plus 3 minus 2, so then we'll get that. Now let me just rewrite everything that we have up here. Okay, so just like I said, let's add equation 1 and equation 3, and then subtract equation 2. So if I do the first step, so we get f of x plus f of 1 minus 1 over x equals arctangent x, and then add this. So let's see, let's focus on the left hand. Let's actually focus on the left hand side first. So this is 2 f of x. So this is with this function and this function. But then if I were to subtract from equation 2, then the functions will cancel. So this will cancel, this will cancel, this will cancel, and this will cancel. So all that left. So now on the right hand side, it's just arctangent of x, then plus arctangent of 1 minus x divided by x minus 1, and then subtract that with arctangent of 1 minus 1 over x. Okay, now just divide 2 to both sides. And so we get that f of x is equal to arctangent x plus arctangent 1 minus x divided by x minus 1, then subtract arctangent of 1 minus 1 over x, and then divide by 2. And now I'm gonna actually just box our f of x that we found in black. Okay, so now next we just need to calculate the integral. So that means and so now what I want to do is when we calculate our integrals, I'm gonna rewrite this input as so this is 1 minus x over x minus 1, so that's equal to -1 divided by x minus 1, and I'll just move the negative arctangent to the center. So we're just rearranging our terms, but you know, it's still commutative under addition, so everything comes out fine. Okay, so now we have the following integral. Okay, so now by using linearity, I can actually split this into 3 integrals. So this is like so. So now let's actually calculate each integral one by one. So I'm actually going to do each of these calculations in red. So how about let's start off with the first one over here. So that means integral 0 to 1 dx. Okay. So what I can do is to integrate this. This is pretty easy to show. We can actually do this by integration by parts. So I'll let u equals arctangent x. So that means its derivative is just 1 over x squared plus 1 dx, and dv is equal to dx, and then v is equal to x. Okay, so now let's actually combine everything together. So this means we have that it's 1/2 x arctangent of x, subtract that with 1/2, multiply with our integral of x divided by x squared plus 1 dx. So now what I can do from here, computing this integral, is that I can actually do a u substitution. So I'll just let u equals x squared plus 1, then du is equal to 2x dx. Okay, and then I'm just gonna skip some steps. So this is 1/2 x arctan of x. And so this is actually just subtract that, so divide by 2, so that means this will be 1 over 4 of, let's see, x dx cancels, so it's 1 over u, integrate that, so it's the natural log, and then substitute back in, so it's the natural log of x squared plus 1. Evaluate this from 0 to 1. Okay, so now that's the next step, just calculate our bounds. So let's see, if we plug 0 into this expression, so this is going to become 0, and then 0 squared plus 1 is 1, ln of 1 is 0, so that's 0. So we have 1/2 times 1 multiplied by arctangent of 1, which is equal to pi over 4, so that'll just be pi over 8, and then plug into 1 over here, so 1 square is 1 plus 1, 2, and then so subtract that, so it's 1 over 4 ln of 2. Okay, so that's our first integral. Cool. All right, so now let's calculate our next integral. Let's actually solve this one. So our integral 0 to 1 of arctan of -1 and then x minus 1 divided by 2 dx. Okay, and same method as before. We're just gonna do another integration by parts. So let u equals arctan of -1 divided by x minus 1. Then take its derivative. You're gonna get that this is actually 1 divided by x squared minus 2x plus 2 dx, then dv is equal to dx, then v is equal to x. And then now put everything together, we have it's 1/2 x arctan of -1 x minus 1, and then I'll subtract, so this is 1/2 integral from 0 to 1 of so x, and then x squared minus 2x plus 2 dx. Okay, so now in order to solve this integral, notice that in the denominator, if we do the completing the square method, so we're gonna get that. Let's see if I can right here. Yeah. Notice that if we complete the square, we're gonna get that this is equal to just so it's x, and then divided by x minus 1 squared plus 1 dx. Okay. So now let's actually do a u substitution for here. So I'll let u equals x minus 1. So then du is equal to dx, but we want everything of x in terms of u. So to substitute x for u, so I'll just add a 1. So then this means we get that this is u plus 1, and then divided by u squared plus 1 du. And then calculate our bounds, our new bounds. So when 1 is equal to x, so this will just be 0. And then when 0 is equal to x is equal to 0, so we get that this is -1. And then using linearity again, we can decompose the fraction into two integrals. So we have that it's -1, 0 of u divided by u squared plus 1 du, and then plus 0, -1 of 1 u squared plus 1 du. And that's not hard to show, because we already showed that is simply just 1/4 or 1/2 ln of u squared plus u. So we substitute that back in, so it's minus, yeah. Or it's in u, what am I saying? So this is actually just u squared plus 1. Yeah, so this we have is just 1/2 ln of u squared plus 1, and then plus arctangent of u from 0 to -1. Okay, now just calculate our bounds. If we let u equals 0, then this will be 0. And if we let -1, so this is minus 1/2 ln of 2. And so if I plug 0 into here, so arctangent of 0 is just 0. And then arctangent of -1, that's pi over 4. And I subtract that, so it's just, so now let's just distribute back in. So let's see, 1/2 x arctan of -1 x minus 1. Evaluate this from 1 to 0, and then distribute the -1/2. So this we have, it's a plus 1/4 ln of 2, and then distribute the negative again. So this would be positive 1 over, or pi over 8. Yeah, 1/2. Okay, so now notice that if we evaluate this term actually just goes to 0. So this means our final answer for this integral over here is just 1/4 ln of 2, then plus pi over 8. And you know what? Let me first underline this. Since we already solved these two integrals, how about we combine the sums together? So this means this evaluated integral plus this evaluated integral, we get the finite answer for both. So we combine the sums together, the 1/4 ln of 2 cancels, and we're just left with 2 pi over 8, which simplifies to pi over 4. So I'll put this outside. And now all that's left is we have to evaluate the negative arctangent, right here, arctangent 1 minus 1 over x over 2. Just factor out the 1/2 outside, 0, 1, then arctan of 1 minus 1 over x dx. Now we just have to do a substitution. So actually I'm going to do it this way. So how about I'll let x equals u plus 1 divided by 2. Okay, so that means dx is equal to 1/2 du. Okay, and then okay, so when I plug everything back, so we get our new bounds too, don't forget. So let's see, when 1 is equal to x, so 2 minus 1, so this will be 1, and then when it's 0, so 0 minus 1, this will be -1, and then let's see, plug everything back, so arctangent of 1 minus, so let's see, 1 over here, so the reciprocals flip, so this is just 2 divided by u plus 1, and then well, really the 1/2 is just from distribute to in here. Yeah, the 1/2 just distributes here, so this is 4 du. Okay, so actually there's an identity we're going to use. So the identity is defined as the following. So arctangent of u plus a divided by 1 minus u times a is simply equal to arctangent of u and then plus arctangent of a. Now if you see, okay, now well, for this, let me just simplify this out. Well, the input I'm talking about, so this is 1, 1 arctangent, let's see, you get a common denominator, u equals 1, so this is should be u minus 1 and then over u plus 1 or 4 du. Okay, so using what we see, we could let a equal to -1, and yeah, so this is -1 and then u, yep, you just flip that, yep, and we get that. Okay, so now using this, I'm going to rewrite, let's see, I'll put the negative out front. That's from, where is it? That's the negative out here. So that means this is from -1 to 1 of arctan of u plus arctan of -1. Okay, and that's divided by 4. Okay, then du. And so arctangent of -1 is actually -pi/4. So that means we get that this is -pi/16, and then plus the 1/4 arctan of u du. Okay, therefore, now I'll just add back the pi/4 from over here. So it's pi/4, and then subtract. Now I can factor out the negatives, so that means this would be positive. And so integrating this is pi/16 u. Let's see, arctangent of u, that's so we have that this is plus 1/8 arctan of u, and then minus 1/16 ln of 1 plus u squared. And then this is from 1 to -1. So I'll just put this on the side. That means this is, if I plug 1, so it means this is pi/16, 1 plus 1/. Okay. So this means that if we combine everything together, they're supposed to be multiplied by 1 here and then multiplied by -1 here. There's supposed to be a u over here. Cease. So yeah, these terms will cancel, these terms will cancel, and so we're left with pi/16 plus pi/16, And so that's 2 pi over 16. And so then it was just equal to pi over 8. Okay, so we have that. So then it's pi over 4 plus pi over 8. And therefore, simplify all this out, we get that it's equal to 3 pi divided by 8, like so. And so this is our final answer over here. Okay, now that's a pretty cool one, if you ask me.